welcome to 7.3 Similar Polygons. In this video, I'm going to go through the notes section and a couple of the practice problems, but I don't think I'll do all of them because I don't think my voice can hold up for all of that. I'm still out sick, but I will be back soon. I'm feeling a lot better. Hopefully, you all are doing wonderful for your subs and very appreciative of them helping you out when I'm gone. So, oops, that's an eraser. Put my name up here at the top. All right, learning target. I can solve for missing sides of similar polygons using a proportionality statement. So let's figure out what similar means to start with. We know that polygons are shapes with straight sides. So what the heck does similar mean? Notes, it says triangle ABC here is similar to triangle QRS. And if you look over at your diagram here, okay, so triangle ABC is this one, triangle QRS is this one. So these two are similar. Breaking it down a little bit, when two shapes are similar, it means that their corresponding angles are congruent. That's your first piece of notes. The corresponding angles are congruent. This is a term that came up a couple of units ago, but in case you forgot what the corresponding angles are, these are the ones that match up in the shapes. So if I take my highlighter and let's get some good colors, pink, and I highlight like this angle here, I'm not going to do it that way. I'm going to highlight it like this. That matches up with angle Q here. So we can write corresponding angles are angle A and angle Q. Hopefully the other ones kind of jump out at you. B down here and R down here, I lined them up the same way on purpose to make it really easy. So angle B and angle R are corresponding. And then the last one would be this guy over here, angle C and angle S. So these ones should be congruent. So like if angle A up here is 30 degrees, you know that angle Q is 30 degrees. If B is 90, then we know that R is 90. Just by definition, if they're similar, then all of their angles are going to match up and be the same. Sometimes it'll be rotated, but you'll see that when we get there. The sides, though, are not congruent. The sides, you can tell, like this side here and this side here, very clearly not the exact same. The sides, on the other hand, are multiplied by a scale factor. This is a word that came up when we did dilations in Unit 3, I think. So when we made things bigger on a graph, we had to multiply them by a scale factor, and that's what's happening here too. In the diagram, the corresponding sides are, well, let's add some color. I'm going to do orange here, so this side is orange, and that should match up with this side over here. A green between these two and these two. And then the last one, ooh, look at that. I did a nice rainbow thing here. Purple here and purple up here. Okay, so now we can tell it what those sides are. So the corresponding sides, the first one would be AB and QR are corresponding. Remember, they're not congruent. They're only corresponding. So they kind of match up if you're looking at them like they're in the same place on the triangles, but they're not necessarily the same length in a similar triangle. The bottom green one there, that's side BC and side RS. And the last one, side AC and QS. And in this picture, each of the sides are multiplied by, well, let's see. So if we're looking at just the orange side here, this one is 4 long. And if we're looking at this orange side, this one is 8 long. So to get from here over to here, we had to multiply by 2. Just double check to make sure that that's true for your other sides. We've got 3 on this side and 6 on this side. Yep, that's also going to be times 2. And up here as well, 5 to 10 is times 2. So our last blank, the sides are each multiplied by a scale factor of 2. Perfect. Scoot on down the page a little bit. We can write a proportionality statement for these similar triangles. So I'm going to try and color code these the same way we did our diagram above. So the first color, or the first sides that it gives us, are A, B, and QR right here. AB in our left triangle was orange. QR in our right triangle was also orange. So you can see that the colors match up here. You're just kind of stacking the colors together. The next one it gave us was RS, and RS I made green. So this box down here should be whatever shape or whatever side was green on our left triangle. Oh shoot, here's my first error. Sorry about the coughing. I hope it's not too loud in your headphones. Okay, whoops, we need to correct my mistake here. So this should not say RS. Maybe you caught this already. This should say BC. All of the stuff on the triangle, or on the top, is from our left triangle. And all of the stuff on the bottom should be from the right triangle. So the big triangle is on bottom, smaller triangle is on top. So this should say BC. Oops, sorry. Okay, but now that would make more sense. This guy is green on the left triangle, and so on bottom we should put the green one that's on the right triangle, and that is RS. I don't know if that makes it too hard to see. For our third fraction, our last set of sides that match up is going to be AC and QS. Those are our purple ones, so I'll box it in purple here. AC goes on top because it's from the left triangle. QS goes on the bottom because it's from the right triangle. These are all going to equal the same number. If I had set it up nicely, it would be your scale factor here in this box, but in our case, it's actually 1 over the scale factor. Don't worry about this box. We're just going to cross that box out for now. On the second side, we can replace it with some numbers. So, same thing. Over here, the 4 came from the orange side, 8 came from orange side. We should correct this. That's not right. This should be how long BC is. BC in our left triangle was 3, and RS in our right triangle was 6. These ones were green, 3 and 6. And finally, we have our purple sides, AC and QS. Purple here, purple here. AC was 5 and QS was 10. All of these fractions, you'll notice, are the same. That's why we can say that they're all equal to each other. This is always going to be true, that these 3 fractions, if you set them upright, are going to be the exact same if you've got similar triangles. So you could reduce this. That's why we started with fractions. 4 over 8 is the same as 1 over 2. This guy here, 3 over 6, oh look, that's the same thing as 1 over 2. 5 over 10, that's the same thing as 1 over 2. So, I know you haven't seen equations like this where you've got like 3 equal signs, but don't get wigged out. It's an easy way of writing a whole bunch of equations at once. It's just saying this is equal to this is equal to this, it's equal to this. We'll get into doing some problems with those later, but it's not too bad. Don't get freaked out by the multiple equal signs. That was our proportionality statement. Scrolling down, we've got some practice problems. I'll go through this first practice section and maybe the next note section with you. And then let you do the rest of the practice on your own. Please make sure you check your answers and the answer key when you're done. All right, this practice section. Find the scale factor from triangle ABC, this guy, to triangle JKL, and then our little hint, what does each side get multiplied by? That's what it means to be a scale factor. This one's a little bit more difficult. So let's find our matching sides. If I want to start, let's do some color coding. I'll make it purple on this side here. Which side does that match up with on the right? Well, it looks pretty obvious that they're oriented the same way. So these two match up with each other, 27 and 36. You might be asking, well, could I use another set of sides? Like, could I use this 36 here and the 48 here? And yes, you can, and you should get the same exact answer that I get. So that's a good way to check yourself or to check that the triangles are similar. Let's use the purple side first. Maybe I'll change my pen to purple too. So we had to multiply by something to get from the left triangle to the right triangle. So we had to take 27 times a number to get to 36. We don't know what that number is, which is why I wrote it in as an x. Now we have an equation that we can solve. 27 times x equals 36. We can get x by itself by dividing by 27 on both sides. And you'll get x equals, let me punch it on my calculator. My computer's not waking up. Here we go. 36 divided by 27 is 4/3, 4/3. So our scale factor is 4/3. You could check that with a different set of sides. So like let's do 36 times something equals 48. We need to divide both sides by 36. And we should get x equals, let's type on the calculator, 48 divided by 36. Oh look, it's the exact same thing, 4/3. Of course, you could do the same thing with the orange sides, but you don't have to. You really only need to do one set of sides. Practice problem number 2, list all of the pairs of congruent angles. So just like we did above, we're matching up the angles that are the same. So I see angle B is congruent to angle K. Angle A is congruent to angle J. And the last one, angle C, is congruent to angle L. Cool. Finally, write the ratios of corresponding side lengths in a proportionality statement. So just like we did up here, this big thing with multiple equal sign in it, multiple equal signs is our proportionality statement. That's what we're going to write for these triangles. So we're matching up pieces of the left triangle on top and the right triangle on bottom. So I'm going to write that down for myself just to make sure I don't confuse things. I'm going to start with the purple sides. So from the left triangle, we have 27 on top and 36 on bottom. That's equal to our green sides, which was 36 on the left triangle and 48 on the right triangle. And then our last one, 21 on the left triangle over 28 on the right triangle. Hopefully the colors make a little bit more sense where those numbers came from. The biggest mistake that people are going to make is flipping their left triangle and their right triangle, or if they're written somewhere else. But just make sure that all of these that are on the top come from the same triangle, and all of these that are on the bottom come from the same triangle. Scooting down, Our second note section is finding a corresponding length. So if you look at the picture over here, we've got two triangles again, but this time we don't have all of the side lengths. We're missing this one here. We don't know what x is. We can write a proportionality statement so that we can solve for what x is. So I'm going to color code again, just in case it helps you. We really only need two of the sides here. We don't need all three. So I'm going to make this 15 orange and this 18 orange. And then in green, I'll do the side with the x and the side with the 30 here. You could certainly use that bottom side, but you don't have to. You only need two of the sides to write your statement. Then we'll do the left triangle, or I can't call it a left triangle anymore. We'll put the top triangle on top triangle, and the bottom triangle on bottom. That makes sense to me. So the sides that should go on top for the orange is 15 over 18. And then the next part of the proportionality statement was an equal sign. And now our green sides. On the top triangle, we had an x over the bottom triangle is 30. This thing here is what we call a proportion. We're going to do lots of work with proportions. That's really the main meat of what this unit is. So we have 15 over 18 equals x over 30. And I think you all solved some proportions, right? I don't know. It's been too long that I haven't been in school. And actually, we kind of jumped ahead. We did step 2 also. You might have just written this out with the sides. So, like, oops. Come back here. There we go. So, ED over MN is equal to EF over NP. That's what it was asking for in step number 1. We jumped ahead to step number 2, where we put the numbers in already. The next step is to make the cross product, which I think you guys should be masters at now. So this left piece of the cross and this right piece of the cross are equal to each other. So we should have 18 times x is equal to 15 times 30. I'm going to punch that into my calculator to make my life a little bit easier. So 18x equals 15 times 30, which is 450. And then finally, our last step is to divide to solve for x. So I'm going to divide by 18. Divide by 18. And I get x equals 450 divided by 18 on my calculator. That gives me 25. So we know that the length of the side up here, that's x, is actually 25 long. And we know that because these two triangles are similar. We wrote a proportion that sets up an equation for us, showing that these sides are proportionate, or that they're related by a proportion. And then we cross-multiplied. We divided by 18 to get x by itself, and that got us x equals 25. I think I will leave you here to do the rest of the practice problems. I'm going to put the answers to the practice problems up on Schoology, so check your work there when you are done. If you get stuck on any of the questions, put a star next to it, and we'll go over it when I get back.